Okay, folks, let's get started. We're just on the hour now. So first of all, welcome to today's webinar. Today we are going to cover what we learned from 1000 Amazon Web Services VPC connections. So before I hand you over to today's presenter, I just have a couple of slides to go through. I will be handing you over to Eric Olson, who is our Senior Director of Engineering shortly. And Eric will take you through the full presentation, and we also have a demo at the very end. But before I do that, I just want to go through a bit of housekeeping. It may be your first time using GoToWebinar. So hopefully by now you can see the screen and you can hear us. If you're having any problems with audio, please make sure you're using the appropriate settings. So if you're dialing in from the US or outside of the US, there is appropriate numbers to use. Or if you're using your mic and speakers, just select the appropriate, and you may need to just adjust those headphone sets or whatever you're using. Secondly, because of the volume of people online today, we have everyone on mute. Please post your questions within the questions pane throughout the presentation today, and I'm sure Eric will remind you. We do have someone monitoring the chat room, Rick Brady, who is our CTO and CEO. So we do have someone monitoring those questions. So they will be answered throughout the webinar as well. Lastly, just in case you need to leave earlier for a colleague couldn't attend, we are recording today's session. So we will be posting that later. And also, as you leave today, we do have a short survey. So if you wouldn't mind filling that in, that'd be great. Also, during today's webinar, we are delighted to offer 100 attendees $100 Amazon Web Services credit to kickstart your SoftNAS Cloud 30-day free trial on Amazon Web Services. The URL to register for this $100 AWS credit will be provided towards the end of the webinar. So if you hold on just before we start the questions at the very end, I will release that URL and you can register for that. So that's it for me. I'm going to hand you over to Eric. So let me just change over to Eric for now. So Eric, if you want to unmute your line, please, and take it away.
Okay, great. Hopefully everybody can hear me okay, and that they can see my screen.
Yes to both.
Okay, great. So good afternoon, everyone. Good morning to those of you that are on different time zones. As David mentioned, my name is Eric Olson. I am the Senior Director of Engineering here at SoftNAS. And we're going to cover some of the lessons that I have personally learned along with some members of my team in over 1,000 different VPC deployments and configurations that we've seen. So just a quick overview.
Sorry, Eric, to interrupt. If you wouldn't mind going into presentation mode so everyone could just see it on the full screen.
I'm in presentation mode.
It's not the view that we see. Maybe it's on a different screen if you're going to try and swap screens or something.
Yes, let me make sure that I'm showing the right screen. Is that better, David?
I'm just waiting for it to refresh now. One sec. I don't see any change on my end. No.
I'm seeing in the questions that they see my screen.
Yeah, we see your screen, but and we can see your web browser in the back end with Amazon Web Services Marketplace.
How about that?
It looks like you stopped sharing now. Let me just see. It might be a bit slow. No, it looks like
we're just seeing the title slide down.
Yeah, looks like you stopped sharing.
Yeah, looks like you stopped sharing altogether.
How about that?
Yeah, that's perfect.
All right, my apologies.
Thank you.
So just a quick agenda. We'll cover a brief SoftNAS overview. I'm going to cover some VPC information. Then, the meat of what we've discussed, the lessons that we've learned from the multiple different VPC deployments and scenarios that we've seen over the past few years. I'll cover how SoftNAS fits into those VPCs. I'll give a quick little demo of SoftNAS high availability in a VPC. And then we're going to leave some time at the end to cover, a Q&A. So as David mentioned, as you're going and you have specific questions, please feel free to drop those in the question bar, and we'll get to those at the end. So just a brief introduction of SoftNAS, who we are. SoftNAS is a powerful enterprise class virtual storage appliance that works for both public, private, and hybrid clouds. It's easy to try, it's easy to buy, very easy to learn and use. So you get a very fast and rapid time to value. You get a freedom from platform lock-in, and it works with the most popular cloud computing platforms, Amazon EC2, VMware vSphere, CenturyLink, Microsoft Azure. And for the focus of today's presentation, we're going to primarily focus on Amazon Web Services and VPC. So our mission is to be the data fabric for businesses across all types of clouds, whether they're private, whether they're public, or whether it's actually a hybrid approach. We have a couple of different products that we can leverage. Our first is our SoftNAS Cloud product, which runs on your public clouds, which is our NAS filer for public clouds. We have our Cloud File Gateway, which is for on-premise use to connect to cloud-based storage. Then we have our Object Filer, which is software-defined storage for object platforms, such as Amazon S3, for example. And we also have SoftNAS for service providers, which is our multi-tenant NAS replacement for use primarily for service providers that are leveraging iSCSI and object storage underneath. Just a couple of smattering of some of the customers. We've got over 650 active customers using the product today. And this is just a sampling of some of them, and these are constantly being updated as we add new customers across all of the array of platforms that SoftNAS operates and functions on. So let's get into the meat of the issue today, and let's actually talk about VPCs, or virtual private clouds. So what exactly is a VPC is the first question that people sometimes ask. So it's a virtual network that's dedicated for your environment, right? It's logically isolated from other virtual networks in the cloud, and think of it as your own private data center or your own private network within your AWS account, okay? It provides you with a location for launching resources, such as EC2 instances, for example, as a SoftNAS EC2 instance, or whatever EC2 instances you want that you want to physically isolate into your own private environment. So it gives you some configuration options that are not generally available in the EC2 Classic service, such as being able to configure your private IP address ranges, go ahead and set up subnets, control and manipulate the routing versus route tables, set up different network gateways, which will cover the different types of gateways that are available, and get very granular with your security settings from both a network ACL as well as a security group type setting. When you talk about the main features that are available within a VPC, you can talk about control, right? So you actually configure what is going to be your IP address range, how the routing actually works, whether or not you're actually going to allow VPN access, and what the actual architecture of the different subnets are going to be within the VPC. You have security options such as security groups and network ACLs, as well as specific routing rules that can be configured. Allows you some different features such as running multiple NIC interfaces. You get static private IP addresses, and some of the EC2 instances are actually only available for launch in the VPC, such as the T2s. You actually can use a VPC to leverage and create a hybrid cloud by leveraging the AWS Direct Connect service, which allows you to extend your premise into the AWS cloud over a high bandwidth, low latency type of a connection. And there's actually some network advantages leveraging things such as VPC peering, where you can actually connect your VPC to another VPC. This could be done for your organization, or you could actually use it to connect to other organizations for specific services or specific access if that would require. Plus, you actually have things like endpoint flow logs that can actually help you with troubleshooting connectivity issues or problems that you may be having gaining access into specific services within the VPC itself. Just a couple of notes on topology. VPCs are used in a single region, right? But they are multi-availability zone, which basically means that each subnet that you create has the availability to live in a different availability zone, or you can put them all in a single availability zone, should you like. All of the subnets that you create within a VPC can route to each other by default. The overall network size for a single VPC can be anywhere between a /16 or a /28 subnet for the overall CIDR of the VPC, and that's also configurable for each of the subnets that you want to set within the VPC. It also gives you the ability to choose your own IP prefix. So if you want the 10 network or the 50 network or whatever you'd like your private IP address range to be, that's going to be configurable within your VPC topology. How can you gain access to this VPC, and how do the resources within it actually gain access out? There's several different types of gateways, and one of the things that we get asked quite frequently is what does each of these gateways do? How do they work, right? So there's this IGW and VPG and CG, and what do they mean, and how do they function? So hopefully this gives you a pretty brief and easy explanation. The IGW is actually the Internet Gateway. So this is an ingress and egress Internet access. So you can point specific resources within your VPC via route tables to actually gain access to the outside world via the use of the Internet Gateway, or you can actually leverage a NAT instance, and more about NATing later. Right? And then when it comes to actually providing VPN access into your VPC, whether that would be done via, like, say, Direct Connect, where you had dedicated bandwidth to connect to your VPC, or leveraging a hardware-based VPN, there's two parts. There's the VPG, which is the virtual private gateway, which is the actual AWS side of a VPN connection. And then there's the customer gateway, which is the customer side of a VPN connection. And most of the major VPN hardware vendors have supported template configurations that you can download directly from the virtual private gateway interface within your VPC via the AWS console. How do the packets actually flow within a VPC, and understanding why different configuration options actually cause different things to happen? Let's just take a sample setup in VPC, and let's actually talk about how the packets will flow and how you would connect. So in our example here, we actually have three subnets, the 10.0.0.0, the 10.0.1.0, the 10.0.2.0. We've got three instances. Instance C here is connected to subnet 3. Instance A is connected to subnet 1, right? And instance B actually has two elastic network interfaces, or ENIs, that are connected to two different subnets, right? Subnet 1 and subnet 2. And understanding the logical flow of packets within a VPC really was an eye-opening and enlightening experience for me and my team that allowed us to actually be able to troubleshoot and deploy environments a lot better. So let's talk about how instance A and instance B actually connect to each other over subnet 1, right? They're both living in the same subnet, right? So by default, the routing table, right, is the first thing that it hits. And that routing table has automatically a default route associated with it to route to all traffic within, the overall CIDR of the VPC. Next, it hits the ARP table, the outbound portion of the firewall. A source and destination check actually occurs, which is a configurable option within AWS. Then it hits the outbound security group, which by default, the outbound security group is wide open. Okay, all traffic is allowed out. It then goes over to the other instance and checks the inbound security group, a second source and destination check, and then it hits the firewall before the packet actually flows into instance B. So it's very common. A lot of times people will say, well, I can SSH, or I can't SSH, or I can ping, but I can't ping. And a lot of the problems that people experience in troubleshooting connectivity here is primarily around these security groups, primarily on the inbound side, because the outbound is actually open by default. So this is usually the first place to check when you're having some type of connectivity issue within the VPC to ensure that the security group is not actually blocking the type of traffic based upon either source or destination IP or port number, for example, that may be impairing your connectivity. Now, where it gets a little bit more complicated is that how would the packets flow to instance B and C? So let's just go quickly back to make sure that we understand that we've got instance B, which is living in 2 subnets, and instance C, which is actually living in subnet 3. Right? So how would that actually look? Right? So if instance B wanted to talk to instance C, right, it can go one of 2 ways, right? It can go out subnet 1 or subnet 2, but the same actual rules apply, right? It's going to hit the route table, go to the firewall, source destination check, security group out. It's going to check the route table to make sure that it has a route to that destination network. And then because it's going to a different network, it's actually going to check the network ACL out. And then on the reverse side, as it comes back in, it's going to check the network ACL in before it checks the security group. Right, so it's different types of connectivity options for instances that happen to live in a different subnet, right? So this is some very important information. Hopefully you'll find that it's useful. I know that from my perspective and my team's perspective, once we really understood how the packets flowed, where they were going to, how everything was being checked and designed, it really allowed us to understand a lot better troubleshooting and looking at different connectivity issues. So let's talk about some of the lessons that we've learned in all of these multiple different VPC scenarios that we've seen. And I've personally put my hands on, 85% of these, 1,000 plus VPCs, either from, different tests that I've ran and created myself, or engaging with customers from deploying SoftNAS in their environment, troubleshooting SoftNAS in their environment, etc. So the first thing is to be very organized with your AWS environment, right? I highly, highly recommend that you use tags, and you'll thank me for that tip later on one day, because as you continue to add instances, create route tables, subnets, all kinds of different things, it's nice to know what's associated with what. Right, and the simple just use of the tags will make life so much easier when it comes to actually troubleshooting things. Make sure you plan your CIDR block very carefully. I would suggest that you go a little bit bigger than you think you need and not smaller. Remember that every subnet that you create, AWS takes 5 of those IP addresses per subnet. Right, so when you create a subnet, know that off the top there's a 5 IP overhead. Avoid using overlapping CIDR blocks, and the reason being is that at some point you may not want to do it today, but you may want to do it down the road. You may want to peer this VPC with another VPC. And if you have overlapping CIDR blocks, the peering of the VPC will not function correctly. And you're going to find yourself in a world of configuration nightmare in order to be able to get those VPCs to peer. So try to avoid using overlapping CIDRs. And always save a little bit of space for future expansion. There's no cost associated here with using a bigger CIDR block, so don't undersize what you think you may need from an IP perspective just to try to make it clean and easy off the bat. You can subnet your way to success, right? And so understanding what is your subnet strategy going to be, right? I would suggest that you align your subnets to different tiers if humanly possible, such as DMZ/proxy layer, ELB layer if you're going to be using load balancers, application or database layer. Remember, if your subnet is not associated to a specific route table, then by default they're going to the main route table. And that little tip right there has caught up a lot of people in my dealings where they created this route table and they've got a subnet, but they never associated the subnet to the route table that they thought they did. So the packets aren't flowing where they think that they are. I would suggest that you put everything in a private subnet by default, and use either ELB filtering and monitoring type services in your public subnet. You can use NAT to gain access to public networks. I would highly recommend, and you'll see this later, that you use a dual NAT configuration for redundancy. There are some great CloudFormation templates that are available to set up highly available NAT instances, and make sure that you size those instances properly for the amount of traffic you're going to actually push into your network. You can go ahead and set up VPC peering for access to other VPCs within your environment, or maybe from a customer or a partner environment. And I would highly suggest leveraging the endpoints for access to services like S3 instead of actually going out either over a NAT instance or over an internet gateway in order to gain access to services that may not live within the specific VPC. They're very easy to configure, and they're actually much more efficient and have lower latency by leveraging an endpoint than actually going out over a NAT or over an internet gateway to gain access to something like S3 from your instance. Okay. Control your access. Don't get lazy and just put a default route to the internet gateway so you can get out. I see a lot of people that do this, and it comes back to cause them problems later on. I mentioned to use redundant NAT instances. There is some great CloudFormation templates available from Amazon on creating a highly available redundant NAT instance. And again, make sure you size those instances properly. The default NAT instance size is an M1 small, which may or may not suit your needs depending upon the amount of traffic you're going to use. And I would highly recommend that you use IAM for access control. Especially configuring IAM roles to instances. And remember that IAM roles cannot be assigned to running instances. It has to be set during instance creation time, and using those IAM roles will actually allow you to not have to continue to populate AWS keys within specific products in order to gain access to some of those API services. So how does SoftNAS fit into VPCs? We have a highly available architecture from a storage perspective, leveraging our Snap HA capability, which allows us to provide high availability across multiple different availability zones. We leverage our underlying secure block replication with Snap Replicate, and we highly recommend using Snap HA in a high availability mode, which will give you our no downtime guarantee plus a 5.9 uptime. And also, it's important to remember that Amazon provides no SLA unless you run in a multi-zone deployment, right? So a single AZ deployment has no SLA within AWS. And just a quick reminder as we're going, if you have any questions so far, then please go ahead and put them in the question box, and we'll get to those. So we have two methods of actually deploying our cross-zone high availability here at SoftNAS. The first is actually to leverage the use of elastic IPs, where you have two separate controllers, each in their own availability zones. They're actually placed in the public subnet, and we assign each node an EIP or an elastic IP address. We use a third elastic IP address as our VIP or virtual interface. You configure Snap Replicate between the two instances, which will provide you the underlying block replication. And then what happens is that the elastic IP address that's considered to be the VIP IP address is assigned to whatever is the primary controller, and whatever services you have from an NFS, CIFS, or iSCSI perspective will actually mount or map drives to that elastic IP address. And then if there is a failover or failure of the storage instance, then it will move that elastic IP address over from the primary controller to the secondary controller should anything trigger our HA monitor, which looks at things like health of the file system, health of the network at multiple different levels. This is applicable for doing things like backing EBS with SoftNAS, using S3 with SoftNAS. Any of the AWS storage types can be leveraged here to give you a highly available, architecture utilizing elastic IP addresses. The second mode is to use a private virtual IP address where both SoftNAS instances actually live within the private subnet and don't have any access out. And what you would actually do there is it's the same underlying snap replicate technology and monitoring technology. However, what happens here is that you actually pick a virtual IP address that is outside of the CIDR block of your VPC. Your clients map to it. There's an entry that's automatically placed into the route table. And should there be a failover occur, we'll update the route table automatically in order to route the traffic properly to the proper controller that should be the primary at the time. This is probably the more common way of deploying SoftNAS in a highly available architecture. And so just a couple of common mistakes, and this comes from my support team, that they see that customers do, is that each of these deployment scenarios require two ENIs or two NIC interfaces, and both of those NICs need to be in the same subnet. You need to make sure that you check this when you're creating your instances or adding the ENIs, and make sure that both NICs are in the same subnet. The other common is that one of the health checks we actually perform is to do a ping between the two instances, and the security group isn't always open to allow the ICMP health check to happen, which will cause an automatic failover to happen if we can't gain access to the other instance. We do actually leverage an S3 bucket here in our HA deployment as a third-party witness. So if you deploy SoftNAS in your private subnet, we do need to gain access to the S3 either via NAT or the configuration of an S3 endpoint within the VPC. And again, as I mentioned just a few moments ago, for private HA, a virtual IP address must not be in the same CIDR of the VPC. So if your CIDR is 10.0.0.0/16, then you need to pick a virtual IP address that doesn't fit within that subnet. So say 50.0.0.0.1 would work in that particular case, or whatever works for you best. But it cannot fall within the CIDR block of the VPC, or the route failover mechanism that we're leveraging will not function properly. So I've got a quick demo to give today. I've already pre-staged the demo, and I've launched a couple of instances via the AWS Marketplace. So for those of you that aren't familiar with SoftNAS, our product is available on the AWS Marketplace. You can just go to the Marketplace and search SoftNAS, and you'll see all the different options for 20 terabytes, 1 terabyte, 16 petabytes, whatever it is that you may need. And again, those are available via the AWS Marketplace. I've already launched my Marketplace instances and have them up here and running, so let me log into them. And let's go through a very just quick setup of HA and actually how that works. And just in the interest of time, I've pre-staged these instances a little bit and done some of the basic configurations. So just to go through some of that, you'll see that I've already added a couple of EBS disk devices to my instance here. And so I have my disk devices that have been created, and they've already gone ahead and been partitioned and set up, and they're actually used already in a storage pool that I named Tank. So I have two 8 gigabyte EBS disks inside of a storage pool that I've already created that I'll show you here, that's called Tank, that's set up into with those two disks in a RAID 0. And underneath of that actual storage pool, I've configured two NFS volumes, V1 and V2. So those would actually be accessible. So if you were actually allowed access via my security group, you could use this IP address right here and mount NFS to those specific volumes, and you would have access to storage. After you've gone through the steps of setting up your disks and partitioning them off and creating a pool and a volume, I've already gone ahead and set up the first part, which is the actual snap replicate. piece of this. My replication is already set up. We're actually replicating here, and you can see that I'm on the source node, and that my replication is underway for both volume 1 and for volume 2. So now, creating a highly available solution out of these is really simple. We're just going to click on this. We're going to go to next, and we're going to select which type of high availability do we want. Do we want the virtual IP, which is in a fully private subnet, or do we want to do the elastic HA? And for this one, we're going to do the elastic IP address. I'm going to throw in what my VIP is that I've already accessed from my AWS console. And you'll notice here that it's going to ask for keys, but then it goes away because I already configured an IAM role on this instance that's going to give me the proper permissions to access the API calls that I need to in order to set up HA. And so for those of you that are interested in that, while this is taking about 90 seconds to set up, the documentation for how that IAM role needs to actually look is available within our documentation. And you can, take a look at that IAM role and set that up. As you can see, it's going through the process of configuring HA. It doesn't ask you for any other information other than the VIP, and if you don't have an IAM role, some AWS access keys. Underneath, we actually take care of everything else via an automated fashion to make sure that everything is set up properly and configured for access. While we're waiting for that, if there is any questions, the next section of this is going to be our Q&A section. So please make sure that you get your questions in so that we can go ahead and get those answered for you. So this has got about 40 seconds left or so here, and this will finish up. And what you'll notice is that this will take those two instances, and this is my second one that I've actually got configured right over here that's ready to go. It will set them up into a high availability pair. You'll see what the VIP IP address is going to be. And then at that point, all of the servers that you had or clients that you had within the VPC can mount either via CIFS or NFS or iSCSI to that particular instance. And you can see that that's now finished. And we've got a good confirmation that our VIP or EIP is actually working. And this is the EIP that is the third address. So access to storage via that IP address is now available. And what will happen is that you can either mount NFS or CIFS or iSCSI, as I mentioned, to that IP. And since this is the source node, if anything were to happen, it would automatically take over to this node here, which is my target node. And storage access would then be available from there. So hopefully you found that the information I provided to you guys is useful. Again, questions, please put them in the box and we'll get to those. And I will pass this over to David now to go ahead and talk about the AWS Marketplace Credit that's available for you guys.
Perfect. Thanks. Great, Eric. Great presentation. Great demo. Just before we pass over to the questions, earlier I mentioned that we are giving away some AWS credit for the first 100 attendees to register. Let me post that URL, and you can see it at the bottom there. It's a bit.ly link. Let me post that URL in the window. Let me just do that now. So I'm going to send that in the chat, so you should see that URL just to save you copying it off the screen. So if you fill that form in, we will be in contact with you, and hopefully you'll start your free 30-day SoftNAS Cloud trial, and you can try that out on Amazon Web Services. So that's that. So next step. So we present you lots of information there, and there was a couple of questions in the questions pane around the recording and slides. We are recording it, so if you attended late, we are recording that, and we will be sending out the slides via SlideShare later tonight. So we want to invite you to try SoftNAS Cloud now. So if you simply go to softnas.com/try AWS. You can try our free 30-day trial. If you want to learn more around SoftNAS and on the AWS platform, we also have a bit.ly link there. You don't need to write these down. We are going to send you the slides. We also have a joint architecture white paper that would be helpful for you. And if you want to learn more from us as well, you can go to thesoftnas.com/contact, and also keep up to date with what's happening with SoftNAS, what events are coming, what webinars are popping along next. We have one next week, which we'll share to you later in the week. So follow us on Twitter, SoftNAS. So I'll hand it over to Rick and Eric, which will go through all the questions. I know there was lots of good questions coming in there. So Rick, if you want to mute your line there, and Eric, if you want to take over and see what questions are in the chat room.
Sure.
All right. Hey, guys.
Good job, Eric.
Thank you.
So hey, first question is, we use VLANs in our data centers for isolation purposes today. What VPC construct is recommended to replace VLANs in AWS?
Yeah, that would be subnets. So you could either leverage the use of subnets, or if you really wanted to get, a different isolation mechanism, create another VPC to isolate those resources further and then actually peer them together via the use of the VPC peering technology.
Okay, very good. Let's see. So you said use IAM for access control. So what do you see in terms of IAM best practices for VPC security?
Yeah, so the biggest thing is that when you deal with either third-party products or customized software that you may run on your web server, that anything that requires use of AWS API resources needs to use a secret key and an access key. So either A, you can store that secret key and access key in some type of text file and have it reference it. Or B, the easier way is just to set the minimum level of permissions that you need in the IAM role, create this rule and attach it to your instance at start time. Now, the role itself can't be assigned only during start time. However, the permissions of said role can be modified on the fly. So you can add or subtract permissions should the need arise.
Okay. And then more questions coming in. So yeah, keep the questions coming if you've got questions for Eric here. Let's see. So the next one. So when you're troubleshooting the complex VPC networks, what approach and tools have you found
To be the most effective.
I love to use Traceroute. I love to use ICMP when it's available, but I also like to use the AWS flow logs, which will actually allow me to see what's going on. In a much more granular basis, and also leveraging some tools like CloudTrail to make sure that I know, what API calls were made by what user in order to really understand what's gone on.
Okay, and then kind of a follow-on to that is somebody asked about third-party products for VPN intrusion detection. Just any suggestions on any of that?
There's a lot of them that are available. We've got some experience with, Cisco and Juniper for things like VPN and, others, Fortinet, whoever, you have. As far as IDS goes, it seems like Alert Logic is a popular solution. I see a lot of customers that use that particular product. Some people, like some of the open source tools like Snort and things like that as well.
Okay. Let's see. Next one. Any recommendations around secure jump box configurations within a VPC for admins?
Yeah. So if you're going to deploy all of your resources within a private subnet and you're not actually going to use a VPN, one of the ways that a lot of people do this is to just configure a quick jump box. And what I mean by that is just to take a server, whether it via Windows or Linux, depending upon your preference, and put that in the public subnet, and only allow access from a certain amount of IP addresses over to either SSH from a Linux perspective or RDP from a Windows perspective that puts you inside of the network and actually allows you to gain access to the resources within the private subnet.
And do jump boxes sometimes also work in hand? Are people using VPNs to access the jump box too for added security? Or
sure, yeah, some people do that. Sometimes they'll just put like a jump box inside of the VPN and you VPN into that. Some people, don't want it to be exposed to the internet in any way, shape, or form. It's just a matter of, your organization's security policies.
Okay. Yep. Let's see. Any performance or throughput considerations when designing the VPC?
Yeah, I mean, absolutely, right? So, it's important to understand that, each instance, has its own, available amount of resources, from not only from a network I/O, but from a storage I/O, perspective. And also, it's important to understand that a 10 gig instance, like let's say take the C38XL, which is a 10 gig instance, that's not 10 gigs worth of network bandwidth or 10 gigs worth of storage bandwidth. That's 10 gigs for the instance, right? So if you have a high, amount of I/O that you're pushing there from both a network and a storage perspective, that 10 gig is shared not only from the network but also to access the underlying EBS storage network. This confuses a lot of people, all right? So it's 10 gig for the instance, not just 10 gig network pipe that you have.
Okay. Let's see. So why you showed earlier, I guess SoftNAS HA. Why would you use an elastic IP instead of the virtual IP?
Yeah. So what if you had some people that wanted to access this from outside of AWS? We do have some customers that primarily their servers and things are within AWS, but they want access to to files, for example, that are running that they're not inside of the VPC. So you could leverage it that way. And this was the first way that we actually created HA, to be honest, because this was the only method at first that allowed us to share an IP address or work around some of the the public cloud things like no layer 2 broadcasts and things like that.
Okay. All right, good. Let's see. It's like the last questions around VPC tagging. Any best practices or example? You mentioned it, but there weren't any examples or anything. So, what have you seen any standards, or how do you recommend people approach it?
Yeah. So I see some people that basically take different services. Like web and database or application, and they tag everything, within the security groups and everything with that particular tag. For people that are deploying SoftNAS, I would recommend just using the name SoftNAS as my tag. It's really up to you, but I do suggest that you use them. It will make your life a lot easier.
Okay, great. So I'm not seeing any more questions. Do you guys see any others?
Yeah, I got a couple here that I see actually that have come in. So let me go ahead and take some of those. So I see one here is storage level encryption a feature of SoftNAS, or does the customer need to implement that on their own? So as of our version that's available today, which is 3.3.3, on AWS you can leverage the underlying EBS encryption. We provide encryption for S3 as well. And coming in our next release, which is due out at the end of the month, we actually do offer encryption. So you can actually create encrypted storage pools, which encrypts, the underlying disk devices. I see another question here, which is virtual VIP for HA. Does the subnet this VIP would be part of added to the VPC routing table? So that's automatically taken care of. That question came from David Christensen, and David, what will happen is that when you select that VIP address in the private subnet, it will actually automatically add a host route into the routing table to allow the clients to route to that traffic. And if you need some more assistance, you can contact us via support, and we'll happily help you get that set up. I see another question here that says, can you clarify the requirement on an HA pair with two NICs that both have to be in the same subnet? That's correct, right? So each instance needs two NIC ENIs, and each of those ENIs actually need to be in the same subnet. Let's see. One question here from Rajesh is, do you have an HA capability across regions? What options are available if we need to replicate data across regions? Is the data encrypted at rest, in flight, etc.? So we cannot do HA with automatic failover across regions. However, we can actually do snap replicate across regions. And then you could do a manual failover should the need arise. And that data that we transfer via snap replicate is actually sent over SSH. So the data could be encrypted in flight and at rest, and you could replicate across region. You could replicate across data centers. You could even replicate across different cloud markets. Let's see. I have another question here around different region HA, so hopefully I've gone ahead and answered that. Number 2, can VPC peering span across regions? The answer is no, that it cannot. Let me see here. Let's see. I have another question here. Can an HA endpoint be created internal to AWS for use with Direct Connect? So the answer to that is absolutely. You could go ahead and create an HA pair of soft NASs, leverage Direct Connect from your data center, and access that highly available storage. I have another question here from Olaf, which is, when using S3 as a backend and a write cache, is it possible to read the file while it's still in cache? So the answer is yes, it is. So I'm assuming that you're speaking about the eventual consistency challenges of the AWS standard region. With the manner in which we deal with S3, where we treat each bucket as its own hard drive, we do not have to deal with the S3 eventual consistency challenges. So here's another question from Bruce. Are there still ongoing legal issues concerning the ownership and use of ZFS? So there is no legal issues concerning ownership and use of ZFS. ZFS leverages the CDDL license. It's shipped as an external kernel module. It's not linked directly into the kernel. So there's no ongoing legal issues there. Let me make sure that I've answered any other questions here virtually. So there's still some questions about is there a copy of this presentation? So David will make sure that the SlideShare link goes out to everybody that was registered for the webinar. So you should be able to share that with your team. Regarding subnets, the example where a host lives in 2 subnets, can you clarify if both of these subnets are in the same AZ? So in the examples that I used, each of the subnets is actually within its own VPC, or assuming its own availability zone. So again, each subnet is in its own separate availability zone. And if you want to discuss more, please feel free to reach out and we can discuss that. I'll give it another minute, but let's see. Oh, here's another question. Is there a white paper on the website dealing with the proper engineerings for soft NAS as far as storage pools, EBS versus S3, etc.? So, the answer is yes. You'll find the link there on the slide that David mentioned, which is our SoftNAS architecture paper, which is co-written by SoftNAS and Amazon Web Services for proper configuration settings, options, etc. And also we have a pre-sales architecture team that can help you out with best practices, configurations, and those types of things from an AWS perspective.
Eric, I see another one. How do you solve the split brain problem? I assume that means with HA and failover.
Sure.
Go ahead.
Yeah, so we actually do a couple of different things here. So when we have an automatic failover, one of the things that we do when we set up HA is that we create an S3 bucket that has to act as a third-party witness. And so before anything is allowed to take over as the master controller or the primary controller, whatever term you prefer, it queries that S3 bucket. And make sure that it's entitled to actually go ahead and take over. The other thing that we do is that after a takeover, the old source node is actually shut down. You don't want to have a situation where the node is flapping up and down, and it's kind of up but kind of not, and it keeps trying to take over. So if there's a takeover that occurs, whether it's manual or automatic, the old source node in that particular configuration is shut down. That information is logged, and we're assuming that you'll go out and investigate as to why the failover took place. If there's questions about that in a production scenario, support@softnas.com is always your friend.
And I see another one. Can we monitor Softnas logs using Splunk, Sumo, and see the rest of that question here? And which log files should we monitor?
Sure. So absolutely. But we also provide some built-in log monitoring. The key logs here are going to be the snapreplicate.log, which controls all of your snap replicate and HA functionality. The snserve.log, which is the Softnas server log, which controls all things done via storage center. And then, of course, because this is a Linux-based operating system, monitoring var log messages is always a good idea. That's just a smattering of those. For more specifics, please reach out to sales and let one of our pre-sales consultants help you out with those types of things as well.
Right now, and I'd like to add on there were a couple questions on Cross Region HA, and that is something we're going to be announcing. We haven't announced yet at reInvent, so stay tuned. Solution to the cross one-to-many, any-to-any replications coming very soon. We're very excited about that. That'll be announced at reInvent.
Okay, David, it looks like I don't see any other questions unless Rick sees some that I've mentioned. I'm going to go ahead and wrap up, and I'd like to thank everyone for taking the time to attend today's webinar. I hope that you found it to be useful and insightful, and that you gained something out of it and didn't feel as if we just completely marketed to you. My goal here was just to pass on some of the lessons that I've learned and some of the different things that I've seen. So as you're making that journey to deploying in the cloud, or you're already operational in the cloud, that maybe I can save you some time from tripping over some of the things that I've tripped over or that other customers have tripped over.
Great, thanks.
So,
Sorry, Eric, to interrupt there. So yeah, thanks very much, Eric, and to Rick as well for going through those questions. As Eric mentioned there, we'd like to invite you now to try Softnas. We do have a 30-day trial, as I mentioned. If you go on to softnas.com/try AWS, you can try it on the AWS platform. And there is also some links there about how you can contact us further if you have any more questions and you'd like to get more information around it. There's various links there on the page that we're just sharing now. As you leave today, just if you wouldn't mind filling in the quick survey, and if you have any other ideas about what you'd like to see for future webinars, please let us know in that form as well. So I hope to see you at the next webinar. So have a good day, everyone. Thanks again for attending.